This is the Amp Hour Podcast, released March 11th, 2018. Episode 383. An interview with Scott Shawcroft. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Scott Shawcroft, a freelance software engineer that works with Adafruit.
Welcome, Scott. How you doing?
I'm doing great. Well, busy day, but I was super excited to be on the Amp Hour.
Yeah, I'm glad we could sneak this in here. You and I were talking after last week's my complaining about J-Link, which I obviously got from the wonderful folks at Adafruit, and I have the EDU version. And you're like, "Hey, did you know I help people with that stuff?" And I'm like, yes, I did know that, but how about we talk about it on the Amp Hour as well?
Yeah. So, well, you just said talk. You didn't say on the Amp Hour, but Well,
eventually all of my complaints and cries for help make it onto the show. So thank you for that.
Well, now more people can learn, not just you.
I'm starting. I've got like a new theory that like my only real value in this world is being a foil. The foil that people can use as a Well, at least Chris asked the dumb question, so I'm happy to ask them, and I will be asking them shortly. Before we do that, let's get a little bit about you. So, what's your background?
I'm a software engineer. I went to the University of Washington and did computer engineering there. And after that, I went to Google and worked on Google Maps for almost 6 full years.
Who's that? Google?
Google?
Google. Yes.
They're a small company out of Mountain View.
Okay.
Actually, in Seattle, the office when I started was not that big, so it did feel like a small company. And I would visit Mountain View, and I'd be like, "Whoa, there's buildings full of people."
Wow, the food is better here.
Yeah. So it was really. Yeah, it felt very intimate when I started, and it grew a lot. The 6 years I was there, I did map rendering. So if you remember, the bike layer came out where you could like toggle the map to see where all the bike lanes were.
Yeah,
that was great. One of the things that I did there was the actual like styling of that.
So how many bike lanes did you have to ride in order to get all that data?
It wasn't me.
I just finished my coding today, and boy, are my legs tired.
Right. No, it's not quite that.
Okay. I always wondered about that. Where did they? I mean, well, probably can't mention where, but I mean, like, it's just like a database that gets pulled in, and then you work on how to make it actually play nice with all the.
Right. So there's a really good article. It's been a while, but one of the efforts that happened at Google while I was there was called Ground Truth. And their whole goal was to take all of the data that we had, satellite, straight view, and turn it into structured data that we could use for products like map rendering or directions or all of that other stuff. So
right. Well, and it's paid dividends over. I mean, like the API people use that all. Like, I don't think I've seen people using the other map APIs that are out there in years now. I mean, like, I know that they still do, and there's other stuff that's out there, but I mean. A lot of people are using that API. Yeah,
and like the data quality is something they invest heavily in, and that's really what makes or breaks an API or
right.
Or
and that is an annoying
product.
Job too.
It's very hard because the world is constantly changing. But yeah, if people want to know more, Ground Truth is the thing to look up.
Okay.
About that.
We'll put
for
a link.
Bike trails specifically, it was a combination of like city-owned bike data that they acquired, plus just information from Rails to Trails, which is this national effort that turned old railway grids into grades into trails.
Yeah, no, I love that stuff. There's one right near me, and it's great because it's like out of the traffic, and it's really good use of former industrial land, pretty much.
Yeah, so when we launched back in 2010. That was like kind of our national coverage was the Rails to Trails stuff.
Oh, very cool. Mm-hmm. Well, so, you eventually got sick of, just solving bike problems and, map problems, whatever. So what happened after that?
Yeah. So I spent 6 years doing software in the cloud, way far away from the hardware. I'd gotten really into quadcopters and drones and decided to kind of pursue that I decided to leave Google and then decided to pursue hardware design for flight controllers, in particular. And there's open source software called Clean Flight and Beta Flight, which are open source STM32 based flight controllers for racing quadcopters.
Okay.
And so I spent about a year developing my own modular flight control system, which I don't recommend people do. I didn't sell very many because they were very expensive. And
yeah, the thing is, modular always needs lots of connectors, right?
Yeah, and I was using Hiroshi 80 pin. I think it was very well engineered. It was
when
just
it's an
way
API,
too expensive.
it's just a couple more characters, right? But that interface, that'll bite your ass, huh?
Yeah, so it did.
Yeah.
But as I got further and further through that, I started talking about what I was doing. Another pro tip is I was in this mode of like, I want to be secretive because it's amazing what I'm doing, when in reality,
right.
people would have
until
told
the
you.
launch, man. Everyone's going to care.
And nobody cares. Yeah.
No, really
but I did start talking about it I was on the MacroFab engineering podcast one time. They were the people that did like my quote unquote production run. And then I had been watching a ton of Adafruit videos because there was really useful like Desco Lady Adas talking about like test jigs and things like that. So I was learning a lot about the production side of electronics through Adafruit. And I had also started doing show and tell to show off all of the stuff that I was making. And after my business product side Chickadee Tech, which is my company, kind of was clear that it was not going to pay the bills anytime soon, I went on show and tell, Adafruit show and tell, and was like, hey, I'm looking for a job. And Phil, Mr. Lady Ada, was like, what do you do? And I said, oh, I'm a software engineer. And he's like, oh, okay. And then the next day he emailed me saying like, hey, we have a project in mind. Are you interested? And I was like, yes.
Sweet.
And I never looked back.
Nice. That's great. I mean, Lamore and Phil, we love them here. And that's a good rule for people listening too. You got to put yourself out there, right? Talk about what you're working on. Sounds like you're showcasing your product. You know, you have a personal site where you showcase stuff. Tan Newt, is it how that's your handle online all the time? Huh?
Yeah, pretty much.
What does that mean? Tan Newt?
It's two words. It comes from like the late 90s when they had these like random word generators.
Really? Wow.
I remember a password I got from something like that. It was like pork-filled pansy. It was another like completely
and now we
random.
all know his password to everything still.
No comment? Not a password I use anymore. But yeah, so Tan Newt was another thing that was randomly generated, and I just thought it was a very funny image. And it turns out to be relatively unique, so I was able to get it in a lot of places, and I kind of just rode that.
Nice.
It is a little hard for people to pronounce, which is something I would consider next time I choose a username.
Right, you click the button a few more times, and then you're good, right?
Right.
Yeah. Okay.
But
yeah, that's great. No, and
that stuck with me a while.
I again pointing to your stuff. It's like this is the classic portfolio style site, and it's good. You're showing off the stuff you're working on, not just where you're
like
working.
My personal website.
Yeah, but also like what
it's kind of out of date, but yeah.
Well, that's okay. But I just mean like the stuff that you were working on. That's an important thing. So if people are ever looking for a portfolio style site, I think this is a good example.
Yeah. I don't update it much, but
yeah, well,
that's what it's for. It's just like links to things that I've done and putting my name to all the things that I've done.
Yeah. So what was this project that Phil said you should maybe think about working on?
They asked me to port MicroPython to the SAMD21, which is at the time it was Atmel, but now they're owned by Microchip.
Yeah.
It's a microcontroller from them that kind of came to market with I think was popularized with Arduino Zero. Mm-hmm. But because of the conflict between Arduino.org and .cc, never really got traction. Mm-hmm. But the SAMD21 got on Adafruit's radar there, and all of the M0 line products run that chip.
Right. And speaking from the other products that I've used from Adafruit, they and you by extension have worked hard to basically make it a more seamless experience from going from the 328, the Atmel 328 P, is that right? Whatever
I don't actually know.
I think it's the P. But the 328, which is on the original Arduino Uno, and now the M0. I mean, it's just like such a significant upgrade, in terms of memory and processing power and everything. It's
right.
Yeah, it's silly.
Yeah, and it's not even it's not a price upgrade either. It's actually tends to be cheaper than the 328s now, I believe.
Right. Yep. Exactly. Because all the M0 parts these days are just so scraping the bottom of the barrel, kind of cheap. So
yeah,
really nice. It's got a lot of the same, or even more. I think it depends on which flavor of the part you have, but it has other peripherals too. So and again, this is the Atmel / microchip version, but like really the M0 and the ARM ecosystem in general, like all of the Cortex stuff. It's just, you get so much stuff for so little money these days.
Yeah.
It's insane, and that's before you even jump into the ESP32 world where it's like, even cheaper, way more stuff, but obviously not as accessible.
Yeah.
So how did you feel about all this? I mean, you were doing STM32 stuff, right? So did it cross over pretty well or what?
I had only dabbled in it a little bit, like most of the Betaflight code I was working with, like they did the hard part. Is understanding that like pin mapping was a thing and figuring out like how pins mux together. That's most of the experience I got with the STM stuff.
Mm-hmm.
And then bringing MicroPython, which is actually STM32 by design, or with the Pi board, which is kind of its flagship board, over to the SAMD21, it was kind of a matter of learning to interact with all the peripherals and making that work.
Got it. Okay. Well, and I should mention too, so this is when it was still MicroPython at Adafruit, right?
Yeah.
And we have had Tony on the show. So your coworker is Tony DeCola, who also works on MicroPython, now CircuitPython. But Tony's been on the show before. So yeah.
Yeah. Really early on, I think, as well.
Early on for us, or early on for him?
Early on for MicroPython at Adafruit.
Yeah, I think so too. And Tony was showcasing a bunch of this stuff as it was being used more and more at Adafruit, I think.
Mm-hmm.
But it seems like it's taken on a kind of a bigger role there.
Yeah, within Adafruit.
Yeah.
I mean, I don't actually have much experience with Adafruit prior to that because I was actually hired to work on it.
Uh-huh.
So my view is very SAMD21 MicroPython centric. But the impression I get is that Limor and Phil have really bet on MicroPython and CircuitPython as a platform for the future.
Yeah. No, I think it's really smart too. I mean, and it's interesting. Like, obviously, I know you don't want to speak for them, and I'm just speaking as an outsider. But like watching all that Arduino crap, it was like the biggest risk for me as a user. Not even for people that were selling it and their livelihood based on products that were using this software. It's like, if that centralized tool went away, me and Dave talked about this too. It's like the centralized tool of Arduino is the real value there, right? The hardware was varied throughout the ecosystem and ultimately didn't matter as much, right? Obviously, it was using a very old processor, but I think that this move too is like basically it's accessible still. It has all the same things. It's accessible, maybe even more so because it's closer to Python. It loads fast and it works pretty seamlessly with the hardware because of the stuff you're doing, the stuff Limor is doing, the stuff Tony's doing. So I think it's a really cool move. And I've been using it, and I like it a lot, actually. So,
yeah, I was happy to hear that you like it a lot.
Yeah. Maybe, can you give people like a feel for what it is if they haven't listened to that other show with Tony?
Yeah, so I was thinking about this in the car, how I would answer the question, what is CircuitPython? And I think what we should talk about first is what Python is.
Yeah, indeed. What is Python?
Right. So Python is a programming language, which is programming languages are a way that you can tell the computer what to do. And when I talk about what computers are good at, I like to say that they're very fast at being very dumb.
Okay.
So they're so fast you can't tell that they're extremely dumb. But programming languages are human readable forms of telling the computer what to do. gets boiled down to binary version that the computer can understand.
Okay, I like that. That's a very high level. Yeah, that's good.
Yeah, we were talking about that too, about
Yes,
top-down
top down, right? Yeah.
Yeah. So I wanted to start there, and some people may be familiar with programming languages like C, really popular in the embedded world, and that lives kind of from the hardware up in my mind, whereas Python is a couple decades old, and it really grew up on the other end of the spectrum of it's really good for beginners and novices. A lot of schools have moved to using it instead of languages like Scratch or Java in their intro courses.
Or C++ in my day. Yeah.
Or C++. Yeah, I learned
Not
Java.
friendly. Yeah.
So it's hit that sweet spot with novices. And I would also say that because its strength is there, it's also grown into a variety of not traditionally computer savvy spaces. So it's very heavily used in data science. It's heavily used in hard sciences.
Yeah.
Because it is so accessible to people who don't do programming as their day job.
Yeah, it's like a language of math. It's like a math helper. It's a spreadsheet helper. It's a whatever helper. Right?
Yep.
Like the what's that one book, the Automate Everything? I think it's a No Starch Press book.
Yeah, I know what you're talking about. I can't remember what it's.
But it's a book basically where you can automate tasks using Python, and that's what a lot of people use it for. Like, so
Right.
it depends on the audience you're talking to. It feels like it's like
Yep.
some people are doing text manipulation, some people are doing image manipulation, some people are. It's really data manipulation.
Some people
at
are
the human
Instagram.
level. Some Instagram, really?
Yeah, I think.
Really?
I think it's Instagram.
Oh, wow.
They were one of the keynotes at PyCon last year. They were talking about switching all over to Python 3.
Oh,
so
yes,
it does scale.
The ultimate. We don't need to talk about that. Yeah. Yes.
So,
and server front end back end type stuff too, which is fun.
Yep.
Again, not really what we're talking about here, but now it's taking that similar user friendliness and kind of diving down to lower levels.
Well, it's bringing it to a new platform, I would say. So,
Yeah.
MicroPython and by extension CircuitPython bring that ease of use that Python has to the microcontroller world.
Yeah.
And I should say that also Python and CircuitPython have this strength where it may not be the fastest to execute, but it's really fast to iterate.
Yeah.
And for beginners, iteration time as low as possible is a good thing, because that means that you change the code and you immediately see how you've impacted the behavior. And getting that down is super critical. And that's a trade-off that I think Python had made previously and CircuitPython makes as well, that has really caused it, or is one reason that it's very, very popular with beginners, is because of that very fast iteration time.
That sounds right. Yeah, and I think so. Another thing that really never sunk in, and I'm not sure if you and I talking about it now would matter for it's sinking for people listening rather. But the whole like interpreted versus compiled, I never understood what that was until I started using MicroPython, CircuitPython. So can you try to explain that? Maybe I'll try to explain it if I don't understand what you're saying.
Sure. So the question is what is the difference between something that's interpreted and something that's compiled?
Yes.
So, for example, Arduino is compiled. Arduino is C++ under the hood. They do some funny tricks to make it proper C before they actually compile it. But the advantage to that is you have a very strong computer like your desktop or your laptop that can spend time optimizing the code for you. And then in the end, what you end up getting is some code that runs directly on the CPU. And what I mean by that is that code that you wrote leads to instructions that the CPU can directly execute.
Right. It's basically taking it from, let's say, C++, and it's making assembly, right? Which then gets... Well, you can view it as assembly, but it's really just have these instructions that relate to machine code.
Yeah,
right?
Yeah. It literally is machine code where
shift left or jump or
Yep.
whatever.
Yep. So interpreted languages have an extra step where instead of when you compile something, you get machine code, you get what is called bytecode, which is a different intermediate layer that does similar stuff to machine code, but in reality, it has a layer of C code essentially underneath it that executes based on the bytecode. I don't know if that is a good enough explanation.
No, that doesn't really help me, actually. Well, I actually didn't even know that was a thing, so that's really what I'm saying. I'm not saying it doesn't help me. I'm just saying I didn't know bytecode was a thing. So
right.
I always thought the interpreted piece was like, now basically you have written a small application that sits there and is like what's it called? What's the bug that they stick in your ear in Hitchhiker's Guide?
I'm thinking earworm, but I don't think that's what
it's
you're
not.
thinking.
Yeah, it's a Babel fish. It's a Babel fish for going. So it consumes some kind of code and it craps out machine code, right? And it does that live though, versus doing it once and then always just pushing that crapped out machine code to your device. Now, now the Babel fish lives on your device. Does that sound right or no? Is that a weird? I mean, it is weird, but
I don't. I understand what you're saying, but I when you load a file in CircuitPython or MicroPython, you don't, and I think Python works this way as well. You don't get out instructions that are equivalent to instructions that the CPU knows about.
Oh, okay.
Instead, what you're getting is, what you have is you have a C function somewhere that reads the bytecode and then does some stuff.
Interesting.
So there is a layer of indirection there.
But it's not like there's not some machine that's sitting there and just consuming. You're saying that it's consuming the intermediate step that you're loading into there. It doesn't care. It doesn't need to do it dynamically. It doesn't need to keep going and going and going and retranslating.
Right. So it does, like CircuitPython will translate your source code to bytecode up front.
Okay.
It'll do that once and then it'll execute it just like the machine would do machine code. But that bytecode is dynamically loaded, not. It's the bytecode is stored in RAM. It's not stored in your flash every time.
Oh, okay. And does that distinction matter too then? Because because maybe that's a good comparison point as well, right? So so you compile something, you have an Arduino sketch, you compile it down, you're going to load that into Flash, and then when you hit go, it's going to hit reset and it's going to load the Flash into RAM and operate out of RAM, right?
Right. So in comparison, CircuitPython, what you've loaded into Flash is basically your tools. So your compiler, you've loaded in there as well. And so there's some code that says like, hey, I'm going to look for this file, code.py. I'm going to load it. I'm going to convert it to bytecode, which I'm going to store in memory. And then I'm going to run what is called the virtual machine, which is a big, complicated loop that I don't really understand. That's written in C. And it interprets those bytecodes into machine code.
But it only does that once, you're saying?
So it'll do that the first time it starts up. And then the way CircuitPython works, if you save the file again, it will stop that VM. And then it will go through that process. It will parse the file into bytecode and then rerun it again. Okay.
See, the VM in that case would be the Babel fish in my weird example. So yeah. Okay.
Yeah, right. I guess I'm thinking what is stored. It's machine instructions for your code is never stored. It's interpreted from bytecode.
Machine instructions for your code is never stored. Never stored in Flash?
Correct.
Okay, because that's like what an Arduino does.
Yes.
Or that's what, right.
Right.
Okay.
What we store in Flash, our Express boards have a separate Flash chip that stores the text version of your code.
Oh, okay.
So
interesting.
It's always dynamically compiled to bytecode.
Right. Okay, so that was a lot of discussion.
Yeah, that was in the weeds.
Let's zoom back out and so practically, how does this work then? So someone buys a Trinket M0, which is like my new favorite board, and I think I've said that on the show before.
Yep.
Which has a little SAMD21 on it.
Yep.
And it's, 8 pins, 10 pins, something like that. What do they do?
Yeah, something like that.
So
it ships with CircuitPython. So all you have to do is you plug it into your computer, and it will show up as a USB drive, and it will have example code on it in a file called code.py, which you can double click and open in a text editor, which you may have installed already. If you don't, Atom is a great text editor. You edit the file, you hit save, and it runs on the board.
That's pretty crazy. That's what I've talked about on the show before, but that kind of iteration loop is kind of insane.
Yeah, for seasoned programmers, it's kind of like I don't want it doing that on behalf of me, but then you use it and you're like, it ran before I had a chance to even go to the other window.
Yeah, right.
To see the output.
Right.
And it's really nice.
Yeah, it is.
I'm glad you like it.
Especially for like I've said before, right? It's I said maybe not to you, but on the show, like if I'm just throwing values at a ADC and I just need to read and write to registers, like that kind of thing, that kind of iteration and cycle of like, and it's effectively what I was doing on Arduino anyways, right?
Right. But now you're not erasing the entire chip, compiling and then uploading it all back.
Right. And actually, one other thing that I found out too is about myself is that like that terrible, like when you get like that like feverish troubleshoot. You ever get in that feverish troubleshoot loop where you're like, I'll just change this one thing, save. I'll just change this one thing, save. I'll just change this one thing, save. And I'm like, oh, it's broken, and I can't control Z it, and I've for some reason I'm feverish, so I haven't been like doing revision control or anything like that, and so the thing that was working the first 30 times, and on the 31st time I changed something that I don't remember, I'm screwed. Whereas. Or I save it in a different location or whatever, and I have to actually keep track of that file. And now it's like I pick up a board that I was working on. It was working when I put it down, and I just load it up, and I'm like, oh, hey, here's the file.
Yeah. I was just talking with a friend of mine, Sophie Wong, and she was saying she loves that part of it as well. Just her code's on the device.
Code's on the device. It's just there. I mean, it's probably like it's lulling you to sleep, but
Yeah, I always back up your stuff.
Yeah, right.
But it is still really nice.
Revision control. It's a thing, folks. Okay. So, so we've talked about how it works.
Yeah.
A little bit too much, probably.
Yeah.
But we haven't talked about why it works. That's probably not the right question either.
Why it works?
Yeah, I mean, like, so
I can talk about our goals.
Here? Yeah, okay, that's good. Yeah.
Like, and this gets into a little bit of why we aren't still MicroPython.
Oh yeah, that's good.
Like, our goal is to be an excellent experience for people who have never programmed in their life. Those are the people that we're going for with CircuitPython. And that's not to say we aren't happy to see people come from Arduino or MicroPython or C to enjoy it. It's just to say that like the decisions we make are not necessarily for those people.
Got it. Okay.
The auto reload that you love so much is one example of a decision we've made explicitly to make it easy for those people. Another example is that we call it code.py, and we actually support calling the file code.txt as well, because we're not assuming that the people who have never coded in their life actually understand what Python is or what main is, but may have heard this kind of code as a buzzword.
Oh, okay.
And then we've also made some decisions to change the way that you work in CircuitPython to better match CPython compared to MicroPython, who has made some trade-offs in how you use it in order to get more performance. So we've explicitly chosen to be less performant than MicroPython in order to be more similar to Python, because Python has tons of resources on its own that we want to take advantage of.
So can you give us an example of that?
I can't, like the API stuff?
No, well, like what would MicroPython do that CircuitPython doesn't do? Like you said, it's made to be more performant in MicroPython versus CircuitPython. So like
right. So one example is there's a thing called there's two ways of doing things on an object in CircuitPython. So in C land, you always just have functions. In C++, you have objects. And then in languages like C#, you start to get both attributes and functions. So a function is something you can think of that performs behavior for a thing. So that might be like blink 5 times as a function.
Yeah, it's like a tiny little loop, right?
Yeah. It's
call
like,
this little loop, you say, go do that thing, and then come back.
Yeah, and it takes some time. It does multiple things in a particular sequence. That's what a function is. But in Python, there's also attributes, which is just state, right? It's just, is the LED on or not? Is the digital pin high or low? That's just state that exists, whether you read it or write it or whatever, it's always there. And Python has this really cool feature where you can actually internally use functions to do that. So we've chosen to use properties, which look
There's a lot of words here, Scott. I'm just saying.
I know. I'm sorry.
Yeah. This is like your Google, or internally you're like, oh, everything's an object, right? You're like,
Yeah.
Everything's a bike lane.
let me think about it. So,
well, okay. So you're saying, okay, well,
so say we have a temperature sensor, right?
Perfect. I love tangible examples. Yes.
Yeah. Let me ground it. So the way that we've written our drivers, which we have like 70 now,
Nice.
is that for all of our temperature sensors, the object for that sensor will have a .temperature property.
Okay.
And under the hood, that is running a function because it's actually got to go out over I squared C, set some registers to maybe do the reading and then read the value back.
Got it. Okay. So I call this object, I say sensor 1. I say, this new thing is sensor 1, right?
Yep. And then you say sensor1.temperature.
Right. And that's how I can go and...
As if you were reading X.
Right. Okay.
Yep.
Cool.
But that has a slight overhead to it,
Sure.
which MicroPython has chosen not to use.
Oh, interesting. Okay. All right. So it's kind of just... It's saying...
It's a style thing.
It's like a laundry list of what is capable so that so it's a little bit friendlier, saying, for users, because now they would expect that every time you call a new sensor that it would have a .temperature. Yes?
Right. Not only is it the same, but it's also we're choosing to be explicit in saying this is state. This is something you can read.
Okay.
But it's also something that just is there.
So why doesn't MicroPython do that? Because people were listening last time, hopefully, to Tony.
Yeah.
And I think he talked about some of this stuff. It's been a while.
MicroPython's audience, as I understand it, is more technical folks. So one feature, Damien George is the creator of MicroPython, and he did an amazing job because Python is complicated and getting it running on a microcontroller is really hard.
Yeah.
So
it's like being an editor, you got to know what to cut, right?
Yeah. So the Python core is really, really strong, but the APIs around it have made some decisions to be slightly different from the way that you would do it with normal Python in order to be faster. So that's more of their priority, is being fast.
Got it.
So not using properties is one example of something they choose to do to be faster. They also allow you to do like inline assembly and interrupts and stuff like that. And we haven't even turned it on for CircuitPython.
Got it. Okay. Well, let's talk about the hardware. When I heard that Adafruit was doing CircuitPython versus MicroPython, I had heard or read or talked to someone about. I thought it was because of the hardware focus of it all, but I actually like this mission based of like. I like this. It's more like, I mean, Adafruit obviously has a very large portfolio of products now as well,
right?
And I think that making it a very pleasant experience within that portfolio makes a lot of sense,
right?
So. Whereas MicroPython's like, well, come as you are, whatever devices are out there, we're going to try and make it work for all of them. But there's obviously a lot of hand wringing that goes along with that because you get a new device in, you're like, oh, well, got to redo it for this one now.
Right. Yeah. So, I mean, the fork was originally just created because we were doing SAMD work. And then when I started talking with Damien about, the hardware API, the thing that the drivers are built on, it wasn't clear to me that there was a consistent story across all of the boards that they supported. Like the ESP8266 was one.
Yeah, that's specifically one I used, and I think because Tony told me about it, and it was like, yeah, a bunch of the stuff just didn't work in there.
Yeah. So they have an API called Machine, and it was not uniform across the different ports, which is ports is their term for different microcontroller families.
Right. Right. So using MicroPython would feel similar if you're looking at the code, but if you took the code from your 8266 and you tried to put it onto a STM32, wouldn't necessarily work. In fact, probably wouldn't work.
Yeah.
Well, other way around.
There was no
probably,
guarantee.
Yeah.
There was no guarantee. And so one of the things that I did early on with CircuitPython was it's a software engineering thing, but the idea is that the API is shared. Like the code that implements the API is shared.
Okay.
So the way that CircuitPython works under the hood is that it's all C code, and there's just structs that represent objects that you can use from Python. And so what I did is I factored that out of all the ports and therefore it's uniform across all of them. And then that code just calls other C code that is port specific.
Okay, this is
I know
I'm out of my element, but okay. Well, let's do a little hand waving, and that's good.
So the goal was that one thing Adafruit does really well is drivers and guides, tutorials.
Right. Yes, definitely.
And we wanted to ensure that we had a foundation that was uniform across all of the places we could bring CircuitPython.
Yeah, right. Especially for longevity of those guides, right? If you want to make a guide tomorrow, you don't want to have to rewrite the guide every time a processor changes or whatever, right?
Yes, right. So we want to be able to bring it like early on. We had SAMD21 and ESP8266 support.
Yep.
We just added SAMD51 support in our 3.0, which is in alpha. And we're also adding NRF52 support at the same time.
Nice.
Which is going to be super awesome. And adding that support for those new architectures is actually easier because the Python to C side doesn't need to be redone. You implement some C functions and you get the Python side for free. Right.
So you're basically in C, you're kind of fitting different puzzle pieces together, but you're creating like an in-between layer with C code. Is that right?
Right. So if you say import digital or digital IO,
right,
that maps to a table in C that says like all these names go to
here's
these
what you
other
got,
structs.
right? Yeah, right. Yeah. And here's where their physical pin locations are.
Yeah.
Okay.
Yep. So that's all just like C structs under the hood.
Cool.
So I write more C than I actually write Python.
Well, someone's got to do it, and I sure as hell learned.
Yeah, I mean, that's the whole goal is that you don't have to worry about it. But
right.
I think something Tony did touch on is that, like, for people who feel that it's too slow, there is that avenue for you to write C that can hook into the Python.
Yeah, and I think I talked to Tony after the fact about that because I remember thinking like, oh, well, like, how would I go and take this? Say I did have a new processor, and what if I wanted to port to that new processor? What would it take?
Right.
I looked at it, and I'm like, oh, no, I don't think so.
Yeah.
I mean, that's what your job, that's what your job and Tony's job and Lamore's job and like everybody who's doing this stuff, that's what you guys do, right? I mean, like,
we don't do new platforms that often. The SAMD21's taken us pretty far, but yeah, Dan Halbert and I are currently working on the SAMD51, and Kevin Townsend and Hot Tack are working on the NRF52 stuff.
Wow. Yeah.
Which
so I'm just saying that's a lot of hours, it seems like. So,
oh yeah.
So like a new platform is not like a small thing, and I, for some reason, I thought like, oh well, it sounds like it's this is, but the implementation layer in each on each new platform is the tough part.
Yeah, and we're trying to like share as much code as we can between different ports to make that easier.
Yeah, no doubt.
And we're restructuring to make that more feasible in the future as well.
Cool. So what about because it's a hardware world, right? So if there's a SAMD, let's say 51, right?
Yep.
I don't actually know anything about that processor, but
it's awesome.
I'm sure it is. But say it's a 32-bit part, and then
it's
there's
a Cortex M4.
Okay. But say there's a 32-bit. I meant 32 pin. Say there's a 32 pin part and a 48 pin part.
Yep.
What is the what's the swaparoo? Like, is it as hard to go from those between those families of parts?
No, it's super easy.
Okay, so that's just a remap.
Yeah.
Okay.
Yeah, we for the ports we just have a table of all the possible pins, and then when you have a board with a particular package on it, you just say like, I'm gonna say that I have A1 on this board, and it maps to this one internally to the microcontroller.
Okay. Cool.
Makes it really easy, and the code's written in a way that it's like, oh, you want to do digital I/O on that? Like, we can do that, or we can't do that.
Yeah. Okay.
So that stuff is easy. Supporting new boards is really easy. So like the Itsy Bitsy M0 Express came out recently, and the hardest part of supporting that was like the new SPI flash chip that was on it.
Got it. Okay. Well, you mentioned there's 70 plus drivers.
Oh yeah.
Does that mean then? Okay, so does that driver? So now we're gonna just assume that the three parts that you mentioned are out: the D21, the D51, the NRF52.
Yep.
If you write a driver now, is it approaching the same place where you have a driver for like a DHT11 or a 21 or whatever temperature sensor? Does it just work on all of them?
That's the goal.
I mean, like, is that like? I mean, yeah, I know. I know it's a mess right now. I'm sure, but like, or not a mess, but like it's a challenge.
Most of the time, it's true. Okay. I would say.
So it's almost like you guys are making like a mini Linux for like, because again, as a callback to previous episodes when Jason Kreidner and Robert Nelson were on, right? I was kind of out of my element there. So
yeah, you could think of it as another platform like that where there's a standard API that you can build drivers on.
Okay.
Linux has that, and
cool.
We do too.
Okay.
Yeah.
So what about for the people out there that are like, oh, but I need it to be fast, or I need it to be low power or whatever. So
right.
So I'm sure you get that stuff a lot too.
Yeah, it does come up. And I would say CircuitPython may not be for you. There are other good examples, or like Arduino is better about power and speed, and MicroPython is better as well. I would say you could take a look at those, but I would also say don't optimize too early. Like, make sure that that's what you actually need, and make sure that CircuitPython's actually too slow.
Yeah. Okay. Okay.
Because you're gonna save a lot of time in the iteration cycle.
Yeah. Right, and that is kind of like a top-down idea as well, right? It's like you're just trying to get the function to start with. You're just trying to get something working and a sensor talking. You're trying to get whatever. Yeah.
Yeah.
So
Lamore was just telling me yesterday that we just launched a new temperature sensor in the store yesterday, and she was like, I wrote the CircuitPython driver first rather than Arduino.
Oh, nice. Okay.
Which is a huge milestone given that she's been working in Arduino for over a decade, I believe.
Wow. Yeah, that's awesome.
So to have a system where it's easier for her to get going with CircuitPython, despite all that history, is just so satisfying.
Right. But I understand. I mean, like, and obviously Lamore is doing those new things too. But I imagine that anyone using like as more and more people start using it as a primary tool as well, that would be another thing where it's like, if it's just a friendlier method.
Yeah, totally.
Yeah. It's interesting in the software world too. I mean, like I've leaned on Adafruit for the for borrowing drivers and stuff like that, and a lot of people out there. So I do wonder, like, writing drivers in your mind, is it tough or easy or whatever?
There's always corner cases that make it hard. That's another thing. So my background's software engineering, so I like to think about how to make it easier. One thing that I've kind of played around with that we don't do that much in our drivers, but is making it very easy to just say, like, the temperature is this register, and then it just works. We're not there yet, but we're getting there.
Well, I just think about
like in your Python code, you just map like names to registers, and that's it.
Interesting. Yeah, because I think about, like, when I've done the limited stuff that I've done in C. Like usually I am setting up, but like data structures, right? You have this pretty tight loop. So like in Python, are you setting up like, 8-bit variables and stuff like that? Or is it just kind of this loose, are you just saying like everything's afloat? Is it like that?
Python actually has a really great library module called struct. which comes out of the fact that desktop Python is very well integrated with C. And all this does is it takes a string of bytes and you can tell it like what C type it would be, and it'll unpack it in as if it was packed by C.
Oh, cool. Okay.
So if you have a 16-bit unsigned register, you just pick the character that represents a 16-bit unsigned register, and you'll get a Python int back.
Okay.
So it makes that interpretation really easy.
Okay. Neat. All right, cool. Yeah, that's great. So what were we going to talk about otherwise, though? Oh, okay. So you're doing, so now you have to take all this stuff and implement it now on a ARM processor, which is really the reason that I was wailing and gnashing my teeth last week as well, because I've got this debugger. I want to be, I'm trying to get better at firmware, and I want to do some debugging, and you have to do that too, obviously.
Oh yeah.
So maybe walk us through, like, so you're loading this stuff up on a daily basis onto a SAMD21 and then debugging it directly? Is that the idea?
Yeah, I tend to.
Okay. Can you walk us through some of your steps if you're firing it up in the morning?
Yep, sure. So we use make to compile. So I will make clean and then I will rebuild it. And I'll also start JLink GDB server. So I have on my desk JLink connected to the SWD port that's on a Metro. I'm just straight up looking at it. I also have a 9-volt barrel connector with a switch on it, so I turn that on as well. And then I'll fire up GDB with the binary as an argument, and then I will connect to the JLink and I will load, reset, and run the code I'm working on. The code I'm working on right now actually is SPI flash code. So I actually have a Salier hooked up to the SPI flash that I just use to understand whether my code is working as I expect or not.
Okay. Okay, cool. So, yeah,
is that what you're thinking?
Yeah, that was exactly what I was thinking. That's great. And I think so you and I were talking on email as well about like, so how do you explain what a debugger is in this case? And I was trying to say it's effectively like a serial port into the processor, but you didn't like that.
Yeah, I think serial port, especially from the Arduino land, means text back and forth.
Oh, okay. Yeah, right. I was thinking just more like clock and data, you know?
Sure. Yeah, I mean, on the implementation side, it's 2-wire. Right. I think. I'm a
you need
person,
a ground. You need a ground for return, right? But yeah.
Right.
Yeah,
so, the way that I was saying I think about it is that it's basically controlling what the processor is doing. So, is it stopped? Is it going? Can I reset it? So it's those basic primitives, and then you also have the ability of reading memory. And memory is a very vast thing. It has the RAM that you have, but it also has the registers of the CPU itself, so you can tell where in the code it is. And then it also has all of the peripheral registers, which I've started to think of all the peripherals on a system on a chip just as if it was an I2C device, right? It's not I2C that it talks to the peripheral, but it's essentially that.
Like it's like hanging out in the middle of space somewhere, and if you want to talk to it, you need to know what its address is. You're saying, and
right?
That kind of idea.
You need to know its address. You need to know its register layout.
Yep.
The only thing that's a little bit different from that analogy is that it's clocked, right? It's clocked in with a similar clock line as the CPU. But it really is like something that you have to go out and talk to, and then something that can run on its own as well.
Like if you wanted to just let it freewheel and wait for an interrupt from it, or
right.
Okay.
Yeah, and that I've been doing a lot of work on the SAMD 51, which is like the newer version of the 21, and the peripherals are very similar. And so the code that you write, because you're just talking to the registers of the peripheral, doesn't necessarily change that much.
Oh, really? Okay. The addresses are similar and stuff too?
The memory map is different. So memory map is this idea of like what memory address is it located at. but the actual register layout, once you have the offset, may or may not be that different.
Oh, okay.
So
okay. So you're saying the address space might be wider, but it's pretty similar to, you just change the address and you're like, oh, it's like you moved your house down the road instead of changing
but the
layout
house is
inside
the same
house.
shape. Yeah.
Right. Yeah.
Or maybe you just bolted on a garage, but the rest of it's the same.
Right. Yeah. You can still go walk through. It's still the same. Yeah. That's a good analogy. I like that.
Yeah.
Okay.
Yeah. And it's the same way as if you took a I2C temperature sensor and hooked it up to your, M0 or your ESP8266. Like the temperature sensor didn't change at all.
Right. There might be a new version of it, but you didn't want to break the old version, so you didn't change the base functionality. Yeah.
Right.
Okay. That's good. Yeah. I mean, how much of the debugger is like you said there's there's like play, there's stop, there's you can go and read stuff back out.
Mm-hmm. Right.
How much of that are you utilizing on a like how much do you need to do breakpoints on this stuff?
Well, so breakpoints you can think of as something that's a special way of stopping, right? Okay. A lot of the time, well, a lot of the debugging I've been doing recently, I'm not actually hitting a breakpoint. I just have a loop that's looping until a register is a particular value, right? Like I'm doing DMA and I'm waiting for an interrupt to happen, and I'm checking for the interrupt by just reading a register. And the DMA is not working, so I just Control C and I'm stopped. So I didn't do a breakpoint to stop there. But yeah, breakpoints are a special way of picking where you want to stop when you get there.
Okay. That makes sense.
Yeah.
I guess in that case though, so I feel like I feel like a little guilty here, like because I'm obviously doing a little bit of my own learning as I ask you these questions, and I've talked in the past weeks too, and I feel like I should know some of this stuff, and then I also feel like a lot of this stuff should be on the embedded podcast, but I feel like hardware people need to know this stuff sometimes. I speak for the hardware person.
And I'm like I'm a software person definitely by training, and I have picked up some of the hardware stuff.
Cool. But in this case, like, okay, so say you're waiting for an interrupt and what have you,
right.
But
it's never gonna come because it's broken.
Oh, okay. Say it did show up though.
Okay.
So an interrupt is basically just like a bit in an internal register of the processor, right? That flips from a 0 to 1 or whatever, and then it goes off and does its routine, right?
Right.
But it's not polling for that, right? Or is the debugger actually polling for that?
So my code. So there's two places an interrupt can. I'm SAMD21. There's two places interrupts can live. There's interrupts that are on the peripheral side, and then those interrupts might get joined together to have one interrupt to the CPU. And then the interrupts to the CPU. The CPU says, oh, I have an interrupt and I need to run this other piece of code instead. And that's just a table somewhere in memory that it looks it up when it happens. Mm-hmm. And so it'll pause your code and then it'll jump to where that interrupt table points to. And then in there, your code has to say, like, let me clear the interrupt so I don't get called immediately again.
Okay.
Otherwise, you end up in an infinite loop.
Right.
Yeah,
there's like an interrupt routine you're talking about there, right?
Correct.
Yeah.
It's also abbreviated ISR, interrupt service routine.
Okay.
In
the case of the debugger though, is the debugger sitting in the ISR and looking at that, or is it?
No. So the ISR or the debugger in my mental model is just like it can pause the CPU, or it can tell the CPU like, hey, when you reach this code, pause or stop, right? And so when you set a breakpoint, the GDB side of the debugger, the code on your computer says, hey, you wanted this like particular function, what program counter is it at? And then the debugger says, hey, CPU, when you hit this program counter, stop, please.
Okay.
So it doesn't have anything to do with the ISR, although you could say when the program counter hits the address of the ISR, stop.
Well, I guess the reason I ask about this too is because I was actually, so as I was troubleshooting my clock pin being plugged into the wrong pin.
Yep.
When none of my debugger working.
You learn a lot of other stuff in the meantime.
Right. I was like looking at it and I'm like, oh, okay. That obviously there was a clock and a data signal going back and forth with the debugger, and like they kind of, some of the stuff fell into place. So I do recommend plugging things into the wrong place sometimes. Excuse me.
Like you have a choice.
Right. Exactly. So, but in this case, though, what I'm really asking, I guess, is what is physically streaming back out of the processor, and then who is controlling things? So, okay, so let's go to that case where we're now setting a breakpoint, right?
Mm-hmm.
Is it streaming where the code is, like in the counter? Is that what's streaming back out?
I don't believe so.
Okay. So how does it know when to stop, though? That's what I'm really saying. Like, who's the brains of the operation here?
Well, so the debugger, like GDB on your computer, is the thing that figures out, you said this function and I will interpret it into this number for the processor. And then you'll see that the processor, like the SAMD21, the Cortex M0 Plus, supports 4 hardware breakpoints, which is 4 32-bit numbers that represent the code that it's executing at any one point. And every time it executes, it's comparing against those 4 numbers. And if it hits that 4 numbers, it stops.
Oh.
Like the CPU will stop, and then the debugger software like GDB through the JLink can then understand that, hey, I have stopped.
Okay, so it's not streaming back out. We're at line 1. We're at line 2. We're at line 3. We're at line 4. And then it gets to line 7,461 or something and says, oh, now the computer says to stop.
Right.
It's more, it's counting internally and saying, I just said 761 or whatever they said.
Yep.
And then it says, okay, I'm pausing here.
Yep.
Come and take a look at what's going on.
Yeah, tell me what you want to do next. Like, do you want me to keep going? Or if you do something like what's known as a step, you're telling, like, do the next line of source code.
Yep.
And your computer is figuring out what program counter that is. It sets another hardware breakpoint and then continues until the CPU says, okay, I hit another breakpoint.
Got it. Okay.
Now there's
and sometimes that breaks, right? It doesn't like doing single steps sometimes.
Right. Yeah. Single step can be tricky.
Yeah. Yeah. Breakpoints are better for that. I knew that one because I've definitely had problems with that in the past.
Yeah, and I think that tends to occur if you don't have your entire source code. If your code goes in somewhere that it didn't know it could, like we have a bootloader on our boards, and if you go into the bootloader, but the GDB didn't know about the bootloader, that can get tricky.
Okay. Interesting.
Yeah. So there are like advanced JLinks where it does actually stream data back, the JTrace and all of that high-end stuff. But in general, that's not something I use day to day.
Right. Well, and I was thinking even with like you could set how fast the serial can actually talk between like the single wire debug SWD. Right. You could say its default 4 megahertz. You could say 100 kilohertz, and it won't care.
Right.
But it's not gonna be able to stream data back as fast or at all, really.
Right.
So. Okay, so that makes a lot of sense actually. So then,
so
basically,
pretty dumb.
The GDB server is running on your computer.
Yep.
It's talking through this hardware chip, the Seger hardware chip on the JLink.
Yep.
And that's basically translating it to some kind of serial thing, and then it's going in and saying, all right, I know where to talk to through this quasi-serial port. It's saying, go to this location, set this this weird number, and that's where the code's going to break.
Yep.
And then we can go and poke around inside.
Right.
Okay.
Right.
Any idea how it's actually? So it's like special access into the processor at that point, right?
Yeah, like the debug hardware. If you've ever looked at a diagram for an MCU, it's like right next to the actual processor.
Yeah. So it's
very integrated.
Yeah, you get to like see everything. Which is also why all the hackers are always looking for the JTAG port.
Oh yeah.
I was just talking to Joe Grand the other day with his JTagulator. So they love that stuff because it is you get to be right there and you can poke around.
Yeah, you're controlling the processor and
right.
You're able to read all the memory.
That's pretty cool.
Yeah.
Okay. This is helpful.
Good.
So
I'm glad.
you have a great tutorial about this too. So it's kind of showing a lot of what we're talking about here.
Yeah.
Debugging the SAMD21 with a GDB.
Yep. And that tutorial was kind of inspired by my talking about tracing. So like keeping track of every program counter. That tutorial was written because I had figured out how to use an optional feature on the Cortex M0 Plus. I think it's optional, called the micro trace buffer.
Okay.
And what it does is every time the program counter, so a code executes by just having a program counter that says, I'm executing code at this address. And by default, every cycle of the CPU, that address increments by a fixed amount, right? If it's 32-bit processor, it will go 4 bytes more.
Okay.
But if you have a branch, which is like an if statement, it might not go to that next line, that next address. Instead, what it's going to do is it's going to load a different address. And so what you can do is you can tell where your code has been if you keep track of all of the branches that you took. So the micro trace buffer says, I was here and now I'm jumping to this other part. Okay. It's a history of where your processor, what code your processor is executed.
And that's kept on the device instead of like in the computer.
Right. So the micro trace buffer is a little piece, it's a little peripheral that can actually write to RAM. So you just say like, here's my RAM address that I want you to keep this buffer in. And then you can go back and read it.
How much can you keep in there?
You can change it. I think I had like 256 bytes.
Okay.
So and then
a couple branches.
well, no. One branch is 8 bytes because it's two 32-bit numbers.
Oh, okay.
Where you were to where you're going, and that's all it has.
Got it. So you get about 8 steps then? 8 steps? Yeah. No. 32 steps. Whatever. Yeah.
It's not that many, but it's usually enough to like. It's really handy if you end up in a hard fault handler or something and you want to know why you got there.
Okay.
You can actually basically see the history of where you are. And that guide includes links to a Python script that you can use in GDB to actually tell you like source code line numbers for all of those addresses.
Okay. Cool. All right. So let's zoom back up a little bit here.
Yeah.
So
we should talk community at some point too.
Oh, definitely that. But on this side of things, so one of the things that okay, so let me step back on my stuff. I came from the world of IDEs, right? And this was like again back to that episode with the BeagleBone guys. Mm-hmm. Like I just don't do like makefile. I've not done makefiles and all that stuff. And, and that's something I'd like to work towards for sure.
Yeah.
But I come from the world of IDEs where you basically you download the whole tool chain from one vendor and you just hope to God it works. And and if it doesn't, you call someone and they help you, right? Or you have coworkers.
Yeah.
And so my tact has been like, I want to like learn this other stuff about Eclipse. So I have this stuff, but even so it's like Eclipse is like IDE is basically just a text editor with some hooks into stuff like GDB and everything else. Does that sound right?
Yeah, I would say so. IDEs are integrated desktop environments, right? So they're trying to integrate all of your workflow into one application.
Right. So can you tell us how you're using this stuff? So you said makefiles. So the makefile basically does the compilation and does the linking and does the all that stuff.
Yep.
But
I tend not to use IDEs.
Right. But then what? Right. So then you start the server, the GDB server.
Right.
And OpenOCD as well.
Well, there's the JLink GDB server, and then I use GDB proper to connect to that. Which is just like the GDB prompt command line prompt thing. Okay. Which is, I think, in the guide you can see it there.
Yeah. Okay. And we'll definitely link people there. But I guess the whole thing that I think about is like, so like even the IDE world, right? It kind of felt like FPGAs do this a lot as well. Like there's all these command line tools underneath, and the IDEs are basically calling these tools.
Yep.
And the empowering thing is like you can call them yourself, right?
Yes, totally. And in different orders.
Yep. But that's also a little scary.
Yeah, I think as a software person, command line is not that scary. I think you see it more there. I've definitely felt coming into the hardware world as a software person, I kind of feel that the hardware world's a little behind in terms of software engineering
I would
in
agree
general.
with that, yeah.
Maybe I should pick on Atmel just a little bit.
Like on their with their the studio thing they have
Well, yeah, I don't use Atmel Studio at all, but just the like maybe CircuitPython is very different than other hardware projects where if you're making a toaster and you need the microcontroller code to do one thing, a wizard that says like, how do you want to set up all the pins and then spits out code for you is really great. But we're not that at all. CircuitPython is very, very dynamic. Like we don't know the code that the user is going to write, and we don't know what pin they're going to want to use for something. And so we're much more in this model of like, we just want to download the USB code and use the USB code. We don't want to have to run a wizard every time we want to update our USB code.
Yeah.
And that's Atmel has Atmel Start currently, which is definitely that model. And we've run into that because the SAMD51 is only supported through that.
Oh, really? Yeah, and I mean that's like what the STM32 Cube is, I think, too, right? Like that's like they are these interfaces.
They're wizards.
Yeah.
Yeah. I feel like that was something the software world already grew out of. But that's my bias.
Okay, so here's that's interesting. So what do you do instead? I guess that's probably the best thing, because I'm sure that some of our people listening, like they're at least used to wizards, if not, they like them. So
I think the answer is something that Limor realized long ago. It's good examples and good documentation. The frustrating thing that I have when I'm using Atmel Start, to pick it on it a little bit more, is that I'm working on DMAing QSpy and I can't find an example. Yeah. What I end up doing is I end up going into Atmel Start and I just get a drop down of all of the register values, essentially. Right. And that doesn't help me. I can read the data sheet and understand the individual registers, but I don't have an example of how I actually want to use it. So I think that
I do like that. No, I like that. Like, the example, obviously that fits well with my mindset as well. It's like most people can take that and then, make it extensible to whatever they need to do.
Right.
It's not going to be 100%, of course, but there are almost infinite things you can do. So at least an example gets you one.
Right. Yeah. And the more examples you have, the more starting points people have.
Yeah.
And I think that's something that Adafruit's been excellent at from the start, and something that we really value. You'll see like all of the products we release have, for the CircuitPython stuff, we have API reference docs, but we also have guides and tutorials as well. I think that a wizard is an easy answer to that problem of how do you get people started, but I don't feel like it actually helps that much.
Right, because it kind of hides the actual thing that's happening, right?
It just puts a different... It's asking you all the same questions in a different way. And this is kind of how I feel about an IDE as well. It's like you still need to understand what a breakpoint is, whether you're clicking a button next to the line of code you want a breakpoint, or whether you're just typing it into a command line. Doesn't change the concepts that you have to understand.
Yeah. Like, so it's almost like, so what do you think? So the hardware, the software made for hardware people then is basically removing responsibility, or what do you think? I mean, like, what is that method that they're doing then?
Well, I think a wizard is a reaction to understanding that people don't understand it right away, but not understanding how to teach it.
Yeah.
I think like teaching people to program is really hard. It's something that like all of our CircuitPython docs have been iterated on a number of times already, and it's something we continue to work on. So it takes time and effort to make good docs, but good docs are what are going to put you ahead.
Yeah.
Oh, sorry about that. That's my shade going up.
You have motorized shades?
Automated motorized shades.
Hey, all right.
It's getting dark, so it's opening it up.
Nerd. All right, cool.
Yeah.
Nice.
That's kind of how I got into Adafruit, actually, was doing home automation sensors.
Oh, nice. Okay. Cool.
Yeah,
okay,
I hope that's I don't mean to dump on Atmel too much, but I think
No. I think I think it is an interesting.
tough love.
It's a software person looking at the state of the hardware / firmware industry.
Yeah.
And it's interesting because, well, first off, I mean, like it or not, more software people are entering the hardware than ever, I think. So
Yeah.
it's going to happen more and more. And if the tool makers don't react, then other people are going to react, obviously.
Mm-hmm.
And so it's good to know. From a hardware perspective, coming the other direction, I've been confused no matter what. So if there's a better way to do it, like, bring it on, man. Like,
yeah, and it's always good for people to try different ways of doing things. Like a lot of our more modern boards, the M0s also support Microsoft MakeCode, which is a block-based code editor, and that's a great way for other people to get started if they're intimidated by text editing.
yeah.
There's
Yeah. Well, like,
no
I mean,
wrong
like
way to do it.
Dave always says that, right? So Dave always says, he doesn't want a text editor. He doesn't want a command line. That is just not what he expects.
Right.
And I think, especially like, a lot of the interesting distinction for me is that, like, there's a lot of people that come from like the microchip PIC world, right? And PIC was one of the first ones that felt like to make it really easy for people. But it's also its own flavor of things. So now
Yeah.
anything outside of that is like,
'Cause it's
oh,
not
well, this.
ARM.
What's that?
Because it's not ARM,
What do you mean? Is that why it wasn't hard? Or
or why it's a different flavor from other MCUs.
oh,
This is where you're getting me out of my element because I've never used a PIC. Like,
oh yeah, a PIC was just like it's like I think it was a slightly abstracted hardware, like, yeah, I guess I'm out of my element too.
well, I think maybe what you're getting at is that it's just it was well documented, and within the PIC ecosystem, if you used SPI, for example, you knew how it would work.
Yes, exactly. Yeah, I think there was the PIC way of doing things, and now
Right.
and recently I went over and I tried something. I'm like, oh, I don't even know what I'm looking at either. Right? It's like
Yeah.
it's basically what you get used to, and
Yep.
that's not right or wrong in any case, I think, right? Some people that like the Microsoft stuff you mentioned, or
Yeah.
the Wizards or whatever,
Yep.
some people are just used to it, and I
Yep.
think it's just about having more options for people. So
Yeah. Yeah. The challenge is when you do it as an expense of other things. Like,
yeah,
I would love more example code from Atmel.
right. Well, like you said, like
Handy
the
51.
new parts that are only available in this, in the Wizard
Right.
format.
Right.
So yeah,
Yep.
that does happen. So before we talk about the community stuff, because I would like talk about that too, just to take us a little bit further down the road of how you're using this, and if you could do it specifically from the realm of, I mean, you were porting some of this stuff. I don't still quite understand how the virtual machine works, and
Yeah,
so
I don't
like
either.
oh, okay. Well, we skip that then.
The point is that I don't need to know the intricate details of how the VM works, because that's something that works across all of the microcontrollers in the same way.
So how does that? How? I don't. Yeah, I guess I don't understand that. Like,
It's-
like you said that stuff gets loaded into Flash, right? The virtual machine code
Yep.
that runs it is loaded
Yep.
into Flash.
Yep.
But then what? So like it's written in C.
Yeah, it's written in C. We call a function that says, "Hey, run this file for us," and
Is
it does.
Is it a binary or is it a?
You could. Well, the file itself is text,
Okay.
so it will parse the text and then run it for us from the outside.
So why does it work on every processor? That's
Well, it's C code, so as long as you could compile it across them.
but who's
So when you
who's
install
compiling it though? That's what I mean. So like, it's not machine code.
so the VM is machine code.
Oh, it is. Okay.
The VM interprets bytecode.
Okay. So the VM is machine code that's loaded into Flash.
Yep.
That acts as a little engine that can then
Correct.
that does the interpretation.
Yep.
Okay. So who compiles the VM? Is that's
We do.
done on a computer somewhere?
Yep.
And it says I'm targeting a SAMD21.
Yep.
So use that SAMD21 compiler
Yep.
to take the C code and make machine code.
Yeah, you go to GitHub/Adafruit/CircuitPython/releases and see the latest release. You'll see a number of files for different boards there.
Okay.
Like you can download you said you like the Trinket, so Trinket M0, and that will be the binary format for, that will be the machine code that has all of the VM and all of the data structures to tell you what pin is what and all that.
Okay, so if I wanted to go and configure for a new part or a new board, I'd have to mess with that stuff if I was so bold.
Yep.
Okay.
Yeah,
And then
so you
compile it
named it.
down,
Yep.
load it onto there, and then and I think I actually did this at one point too, because I had taken my Trinket M0, I had put I had taken the CircuitPython stuff off of there, and I had taken it off there. I just loaded a new bit of machine code into Flash using the Arduino. Yeah. Okay.
Yeah, people ask how to uninstall CircuitPython, and the answer is you just write your Arduino sketch over it.
Yeah. Right.
Really.
I figured that out eventually. Okay.
Yeah. Yeah, maybe we should say that explicitly.
Yeah, that's good. That's good. Cool. All right. So that's, but in this case, most people don't need to compile that because it's already been compiled. So that's why it's in the releases folder. So if you write over it in Arduino, so you're in the Arduino IDE, you load up a new sketch, you mess up your CircuitPython thing, you can then go and just load in this new file into Flash.
Yeah.
And then boots up, ready to go.
Mm-hmm.
Boom.
Yep.
You've got some CircuitPython again.
Yes.
Cool. So what else are you using debugging for then? I guess I was going to ask about that stuff, but it sounds like that's it's taken care of. So day to day, what are you debugging low level? So is it like when you're testing out new drivers?
Right. So there's a lot of different levels. I guess I would say what I was talking about previously is when I'm working on core CircuitPython code, but a lot of the contributions that we have to our kind of project and the things that we can do day to day are things that we can just run with CircuitPython. We don't need to get the JLink out.
Yeah.
Right? Like if we're creating a new device driver, we can just use the I2C stuff and write Python code and don't have to worry about it. Like we don't have to worry about the JLink at all.
That's great. Yeah. Right. So you make like these structural things that you're just done with, right? And then you build the tools first and then you use the tools.
Right.
Yeah.
So a lot of the work that happens within like this broader CircuitPython project is driver work and example and guide work, and that all happens without ever needing to even think about compiling CircuitPython yourself on your computer, or loading it with a JLink.
Right. Until you get a new processor type or a new board that has different pinouts and stuff like that, right?
Yeah, you could, if you had new pinouts, you could probably get away with not using a JLink as long as you can load it somehow.
Okay.
Because it's usually not the end of the world if your pinout map is wrong.
Really?
Yeah. CircuitPython has two ways to map pins. One is with the name that the board knows. That's the board module has like A1. But we also have the actual names from the microcontroller itself. So even if you get
you
that
could just
board
like make a
mapping
little
wrong,
map yourself and then you just refer to the pin 37 is the ADC or whatever.
Yeah, you can always refer to PA17 directly if you want.
Are people starting to take, I mean, so are they, let's just stick with the SAMD21. Are people putting a SAMD21 onto a new custom board and then using CircuitPython? Or have you been seeing examples about that? Yeah,
we have a couple people within our community. Deshipu, whose name is Radomir, he did the micro game, which has been on Hackaday. It's kind of Game Boy sized, and it's a SAMD21. It's basically a Trinket, but on a different form factor with a screen. And that's running CircuitPython. He's actually selling those on Tindy.
Oh, cool.
I don't know if he has them in stock, but that's one example. There's another person on our Discord, Sedacious, who is working on their own M4 board, so using the SAMD51. So that's been really nice because they're hammering on the SAMD51 at the same time we are.
Yeah,
and they're living on the bleeding edge of what we're doing, which is really nice.
Right. I'm just imagining imagining a future where there's more and more parts supported by MicroPython, CircuitPython, whatever.
Yep.
Right. I imagine it'd be really nice to have. So I already use like the feathers, which is one of the form factors Adafruit sells, right?
Yep.
So be on a feather, use something like that, refactor, put the exact processor, take that processor, put it on a board that I have, refactor it however I need to, drop CircuitPython onto it, make sure the code's working that I've already had on the other board.
Yeah.
And then eventually, as I need to, then go and refactor or then if I need to, save power or, work on my, the speed of my code or whatever, then I can do it there.
Yeah, you could make some C code for the stuff that's slow.
Yeah. Right.
Yeah, that's totally possible. I built a board myself that's used for a toaster oven controller to replace like the control panel of a toaster oven.
Nice.
To make it a reflow oven, but it's not done yet. But yeah.
I think it sounds like one of the stumbling blocks would be like if someone evaluated or using that method that I just explained, the stumbling block would be if you get to the end and you optimize and you optimize and you optimize and it's still not enough. That's way too late, right? You've already got this thing on your board.
Yep.
So it's like, it's almost like you should, it's hard to do that at the beginning, but.
Yeah, I would say like you'd probably find yourself not using the Python side at all. You'd just end up with a bunch of C.
Yeah.
And that's okay.
Oh, right? Sure. I just mean that from a prototyping. Like it's really, this is all talking about iteration and design as well, right?
Yeah.
Again, like thinking like top down, it's best to start with off-the-shelf modules like a Feather or something.
Right.
And just to get the concept working first, because that's usually the hardest thing.
Yeah.
And if you're waiting for boards to come back, if you're waiting for all this stuff to work, it's like, it's like the longer you wait, the longer you stretch out your decision time of if it's a viable idea.
Right. Yeah. Well, it's a great way to find the things that you do need to optimize. To get going, and there's lots of avenues that you can take to do that optimization because it's open source and it's all C code.
Yeah.
You need the technical skills to be able to do that, but it's possible.
Right.
And
I've talked to people in the past too. I think that over time, and I've talked to the embedded folks about this as well, embedded FM.
Yeah.
And I think more and more people are. Especially people coming up, like they've worked in Arduino stuff before. Now they've worked in MicroPython or even just Python, right? And it's like people that need to get down lower into the stack, like the kind of stuff that you're doing.
Right.
I feel like there's more and more need for that. And if people are listening and know more resources about it, I'd be personally interested. But I think also like that's just a thing that is needed, right? There's no shortage of need for embedded engineers. And
yeah.
So
yeah, and I think CircuitPython's a great way to get started because there are those layers that you can peel back as you find that you need to.
Right. And I think that it'll get more people comfortable with the actual hands-on hardware, which is, in my experience, like the embedded stuff's fine, but like usually even a lot of the embedded folks are like, I don't want to mess with the hardware, but you kind of need that crossover piece,
Yeah. Hardware's super fun.
Not always.
I live in the digital realm. I'm scared of the analog side, but
that's fine.
The low speed stuff, but
yeah, okay.
We
all have really different demons, I suppose. Yeah.
Yeah, I'll get there eventually.
Yeah. No, I think like you said, like writing drivers is you're gonna be hands on with the hardware because you need to make sure the hardware is actually working.
Yeah.
And like you said, that's a big piece of the work. When I think of embedded work that's out there, it is a lot of that. I got a new sensor, I got a new ADC, or I got a new whatever.
Right.
I got to talk to it somehow.
Yep.
That's what that work is.
Yeah, and it's super fast to do that in CircuitPython.
That's great.
And we have people hinting at our community. Like we've asked people to just we had a forum user yesterday who said this temperature sensor is getting stuck at a particular value, and I asked somebody else in our community hey, can you reproduce this? Right, so they're not even creating a driver from scratch. All they're doing is trying to validate this bug that we found.
Oh wow!
And that's super helpful because now I know it's a real bug that I've got to fix.
Yep.
And I haven't done it yet, but I didn't have to.
It was just yesterday. Come on.
Yeah, I didn't have to take the time to be able to tell the difference between whether it was a bug or whether it was just a setup issue. Somebody else did that for me, which is really valuable. So
right,
thanks,
and I think
Phil.
that especially in the Adafruit serves a lot of beginners as well, and yeah, it stinks when you chase ghosts, right? It happens, right? Of course, but when it's oh well, yeah, you turns out you didn't plug in the battery after all,
right?
So yeah,
and we're trying to build out and really encourage people to help other people to figure out they haven't plugged in the battery rather than having us having to do it directly.
Yep. Right. So yeah, tell us about the community stuff. What is this mystical forum / chat that you talk of?
Yeah. So it's been really interesting for me personally, because when I first started working with Adafruit, it was simply port MicroPython to SAMD21, and it wasn't so much about thinking of CircuitPython as a larger project. At some point, we decided to rename it. That was like January of last year. It was like, okay, I think we're gonna take it in our direction and not try to merge explicitly back with MicroPython. So we'll call it something else so people don't get it confused. And at that point, it was like, okay, well, how do we define it? And we talked about this before of being really easy for beginners and prioritizing that, even at the expense of other things. And then we also said, like, we want to do the same thing. We want to be just as deliberate with the community that we build around it. I had seen, at PyCon last year, there was a lightning talk that said, hey, the Rust community is really, really strong. And out of that, I found these really great videos from E. Dunham, I think her name is Emily, talking about how to automate your community. And she meant kind of two things by that. One is setting expectations for behavior in your community up front, using a code of conduct. And that's automating in the sense of you already set expectations. You don't need to manually set them later. You may need to enforce them, but you don't need to set them.
Right.
And then also things like automating some of the menial tasks when it comes to issues and pull requests and things like that. And we've done a little bit of that within CircuitPython, which is like when somebody proposes a new file change, we'll automatically make sure it fits within our style. If it's a CircuitPython change, we'll make sure it automatically compiles. Just those basics that sometimes people miss.
Yeah.
So the rest
it would suck a bunch of time if you accepted it and then you're like, oh, I have to read it. I'll just do it myself, right?
yeah. And having that mentality as a maintainer, like I was the first person to maintain Adafruit CircuitPython, and really having that mentality of people coming in to the project are assets. They're not burdens. It may sound simple, but some people see those other people coming in as burdens and want to avoid interacting with those people. And while it does take,
right, you're like assuming success versus assuming failure, right?
Right.
But you set a standard for that success. You're like, well, I'm sure they'll be successful because I said it has to just tabs, not spaces, or whatever.
Right, and it's that's a whole nother thing. Tabs versus spaces. Like automating style is really valuable too. Because did you see what Bill Gates said? I don't know if you saw. Not recently.
He had an AMA recently, and he answered. I'll link it in. People can find out. Tabs versus spaces. Bill Gates weighs in.
What I would say is it doesn't matter either way, as long as you have it automatically found out and reported for all code changes.
What I'm really wondering is when's the last time Bill Gates wrote code? That's all. Why even ask him that question? You know?
Because it's a classic debate that, of course, Silicon Valley also brought up.
Yes, right.
But yeah, I think the more important bit as a project maintainer is automate the answer to that question, so that when you're doing your review, when you're spending your time, you're not spending your time telling somebody to switch their tabs to spaces or vice versa.
Yep.
Because that is like one of the paper cuts that will kill you when working with a community is death by 1,000 paper cuts.
Right.
You want to remove those friction things as much as you can. And the people that are coming into your community can also be really helpful to remove those things as well. The example of testing the device driver to make sure it was actually broken is a great example of that. Like that's one small thing I didn't have to do. Mm-hmm. So
that's great.
The way that we organize our community, which is kind of getting into the tools side of community building, is we do all of our GitHub. So we have the Adafruit support forums, and that's existed for a long time. And that's the place that people can go to get like official support from Adafruit, official technical support. And then we have live streams that happen every week. We have Ask an Engineer and we have Show and Tell, which is how I got the job. And
That's Wednesday nights, if people don't know.
Wednesday nights, 4:30 Pacific, 7:30 Eastern.
Please.
Right. Hey, I'm in Seattle. I gotta do it that way. And what was happening is that we were having people chat in the chat channel with the live streams recurring week to week. And at some point they said, hey, we should have a Discord server. Discord is kind of like Slack, kind of like HipChat, kind of like Gitter, but it grew up out of the live streaming community. And I think that's one of the reasons that it grew. It was the thing that people asked for.
Right. And it also has a voice function like the program you and I are using right now called Mumble.
Yeah.
So,
yep.
Yeah.
Yeah. So Discord's a free application. You can get it on your phone. You can get it on your computer. There's invite link that you need to join the server. We have one that's we have a short link for it. It's adafru.it/Discord. And that will jump you into our Discord server, quote unquote, which is kind of our space where we can have multiple channels. We can set a code of conduct and the moderators can moderate, which I really like. I had experimented with Gitter a little bit, which it has really nice GitHub integration, but it's very vague as to what those boundaries are. Mm-hmm. And so Discord's really nice as a tool for that. So what that brought to our community, and particularly the CircuitPython community, is a way that people can chat all the time and get really quick iterative feedback when debugging. I
was on there a couple weeks ago. Yeah, I was asking questions. Yeah.
Yep. And
Scott was in there. Yeah.
Yeah. It's a balance between paying attention to it and not paying attention to it.
Yeah, right. You got to lock down sometimes and just do the code, right?
Yeah, exactly. Yes. But because I've had this mentality and the people that we've started working with have this mentality of like, above all else, helping people and teaching people is valuable and it's time well spent. That means that we have a lot of people that sit in Discord along with me and can answer questions when I am heads down in code. Mm-hmm. And that is immensely, immensely valuable. And that's also the way that we find people that we want to start paying to do work, which we now have 2 new folks since I came on. So Tony was doing some work, and then Dan Halbert is full-time as well. And Katney Rember is kind of all hands on deck doing stuff as well now for Adafruit with CircuitPython.
That's cool.
So on the team side, we're growing a lot. And then we have like a dozen people. We have a weekly voice meeting that happens on Discord, and you can get the recordings of the previous ones through our YouTube channel. We regularly have a dozen people that sit in on those. And that ranges from people who are, making projects with CircuitPython and just letting us know like things worked, things didn't work, what worked well, what didn't work well, to discussion that Dan and I will have about the DMA and Atmel start and all of that.
Yeah.
But it's one place that anybody can go if they're interested. So everybody's welcome to join that.
That's great. Yeah, we'll have links to all that stuff too. That's great.
Yeah, that's Mondays at 11 Pacific, 2 p.m. Eastern.
Yeah, it's nice. You can just kind of listen in if you want to. You can put on headphones. And
yep. Yeah, just let us know.
Cool.
Yeah, and then... Sorry, go ahead.
No, please.
I've been talking a lot. I was going to say the last thing is we do a lot of our project management all through GitHub. So we have lots of issues, and we have issues particularly marked that are good first issues. So if you want to get into the core work side or the driver work side, there's good first issues that are marked for that. And people are always welcome to reach out to me or any of the other folks to get help with those as well.
What's an example of one of those? So it's like kind of like small things that could be chased down by someone that's new, kind of? That's the idea?
Yeah. Drivers are a great way to start. So say like there's a new temperature sensor, or there's those Nokia phone displays that are kind of prolific.
Oh, yeah.
There's currently an issue out that says like, we need a driver for this. I think one thing that is important in a community like ours is to just ask people to do stuff. And if they say they can do it, believe that they can do it.
Yeah.
And give them the time and the support to be able be able to do that. So that's worked out really well. Like I had some work that I wanted to do with all of our documentation. We've got 70 drivers. They all have their own docs, and I wanted to restructure them a bit to be better. And I was starting to do it myself. And then I had another community member, Mike McWethy, come to me and say, like, he just emailed me saying, like, can I just help with this? And I was like, you know what?
Oh no.
Yes, you can. I wrote up a GitHub issue on it. I had a list of like all of the repos, all of the drivers that needed work, and him and some other folks just went in and checked all that stuff off, and it was amazing.
That's great.
So just ask people and respect that they're giving you their time, and give them the time they need to get over humps, any hurdles that they hit, and it'll pay off. Like,
right. I think this is good too, because this is a little bit, people who are like in school are usually asking like, oh, well, I hear I'm supposed to like join open source projects or like do this stuff. And it's like, this is a little bit more, this isn't quite as like high, this is obviously, it's a commercial venture, right? But it is it's a project that helps people, right? And it's probably a project that could help you build your next sensor into a project. So like there are some real benefits here. So I think that's good.
Yeah. And on the experience side, we work like, I have 6 years experience with Google, and Dan has like 2 or 3 decades worth of experience. So,
so like from a mentoring perspective.
Yeah, from a mentoring perspective and understanding the way that professionals work, it's a very easy way to get in there.
Yeah.
You'll work directly with Lamore and as well as Dean. So like, it's
great.
surprisingly easy.
Hey, I mean, you do the work, you get it gets rewarded, right? So that's good.
Yeah, but we also understand that people are better at other things. Like they have different strengths, and one thing that I went into 2018 really wanting to think about, and there's a blog post I can link you to that I did.
Sure. Yeah.
Is that when I first started working on CircuitPython, it was very much, this is a software project, right? I'm just worried about what I'm going to implement tomorrow, and what hardware is coming down the pike. I'm not really thinking about everything else. But going into 2018 with our community, Discord started in June, and that really grew our community a lot. I really wanted to think about CircuitPython much more broadly than the actual thing you install, right? It includes the guides, it includes the API reference docs, it includes the driver support, it includes the Discord community and the code of conduct and all of these things. These are all things that we need to work on to make CircuitPython as a project really successful. That's something that a lot of open source projects do really well.
Yeah.
But it was it was like a recognition in my mind of like, oh, I'm doing a lot more than just coding every day.
Well, yeah. I mean, you're an organizer now as well. What's coming up tonight?
Yeah, we have the second Seattle Hardware Happy Hour tonight.
He's been revealed as the creator of the Hardware Happy Hour #2. We are the
Oh yeah, yeah. So I
don't think I mentioned that you were the one doing it. So
no, I don't think so. But yeah, Chris,
you're like, yeah, you didn't.
Well, Chris, you deserve a lot of credit because you connected a bunch of us in Seattle here via email.
And there's so many hardware people out there now. What the heck happened?
I don't know.
I think it's the software people coming over, man. You got a lot of software people out there. So.
We do. Yeah. We have a lot of tech.
Yeah.
And hardware is super fun. So I understand why people would go that direction.
Right, exactly. Don't just layer bike stuff onto a map,
Oh yeah.
Build the bike or, instrument the bike.
Yeah, I think the Google AIY kit stuff came out of the Seattle office as well.
Yeah, I've been trying that actually. It's a cool little kit.
Yeah, so
that's good.
Yeah. So you connected us and I picked up time and location last month and one this month, and so we have that tonight. It's very chill like you do in Chicago. It's just hanging out at a brewery, showing stuff off and chatting. So I'm really looking forward to it.
Is there a Kaiser sighting? Can you tell him we said yes remotely?
I'll try to remember that. He RSVP'd yes on the meetup when I saw it last. Okay. So I think Jeff will be there.
Okay.
I didn't actually get much of a chance to talk with him last time because I was too busy talking with other people. So
Yeah, that's good. That's what these like these community things, like hardware and software nerds like talking to each other. It helps when there's beer too, but there's just projects and hanging out and
yeah, it's super fun. I was looking forward to it.
that's good.
For sure, and I appreciate you connecting us.
Yeah,
because I'm kind of bad about it.
Yeah, it's just you just gotta keep it up. Like that's the thing over time. It gets tougher over time. I think that's the main thing.
Yeah, and we don't have a particular space we're doing it in right now, so I
think it's better to move around.
Experimenting.
Actually.
Yeah.
If other people are interested in starting there are franchise opportunities here, folks. The benefits await.
Yeah.
One last thing I think you should mention though is you are going to be at PyCon, right?
Yes, for sure.
In
Cleveland.
Cleveland. I saw that this year. I was like, really? Like, why?
It's next year as well, actually.
What? What is going on there?
Well, the way that PyCon does it is they negotiate hotels and conference centers for 2 years in a row to lower the overhead of doing that.
That's actually pretty smart. Okay.
Yeah, so the last two are in Portland, the next two are in Cleveland, and then I don't know where the next one is after that.
Wow. Cleveland. Bringing it on home. How big is PyCon?
It's 3,300 people.
Oof. Okay.
So we have a goodie bag, or we have an item in the goodie bag.
Oh, yeah?
Which we are not revealing what it is, but it's quite exciting. And it does, I guess I could say it runs CircuitPython.
I mean, that's okay. That's smart.
Surprising.
Yeah. Right. And this one runs JavaScript.
There is an equivalent JavaScript equivalent thing. I don't think it's as popular, but
got it.
Yeah, so I'll be at PyCon. I'll be in New York in April just to visit. So if you're in New York, feel free to hit me up. I'd love to do lunch. I'll be in Cleveland for PyCon, and I'm thinking about visiting Boston for the Open Hardware Summit in September.
Oh, actually, I didn't even know that was decided. So
yeah, I think they just posted it.
Okay.
September 27th at MIT. So I think I'm gonna try to make a New York Boston trip out of it.
Cool.
Because Dan Halbert is based out of Boston as well.
Oh, very cool.
My other core dev.
Yep. Yeah, Boston's a fun town.
I've never actually been
robots up there and stuff. So
yeah, some engineers there too.
Yeah, I guess so.
Yeah, but then I'm based in Seattle, and I'm also always willing to get out and have coffee or tea.
Yeah,
I guess
if you're working from home, you need that break, huh?
I definitely do.
Yeah,
definitely do.
Even a Discord server doesn't cure the stir crazies.
It helps. It definitely helps, but yeah, working from home is a whole nother topic.
I don't know if I've ever. I mean, you listen to the show once in a while, is that right?
Yeah, pretty regularly.
Okay, so I don't know if I've ever mentioned why I joined the workspace I'm out of. There was like, so I tell this story around here once in a while, or usually when I'm at MHub, which is where I work out of now.
Yeah.
People ask like, why'd you join? I'm like, well, I was working remote and I had a really busy day of meetings. And I was on the computer all day long and just talking to people, mostly by text, and I didn't really think much about it. And then about 1 a.m., I'm finally done with everything. I'm working on a board, I think, or something. I fall into bed and I say out loud, "Ah, crap! I forgot to schedule that meeting."
Yeah,
and then I think to myself, well, no, I think to myself, that's the first time I've spoken out loud or left the house in 2 days.
Yeah.
And then the next day I joined a shared workspace.
Yep. Yeah. So I can totally relate to that. I didn't have quite the same experience, but I did like 3 days. I was like, I think I've only gone outside to get the mail and take the garbage out. So I started doing what I call as a commute with air quotes. Where I try to actually get outside for not that long, but just go walk around my neighborhood like in the morning before I get going.
That's
and
good.
then at night as well.
That's smart.
It really helps.
Yeah.
It's been hard
and
because it's bad. But
and then doing like 3H and like meeting with humans and or having coffees like you're saying, like these things are all survival mechanisms of the remote workers.
It is. Yeah, it is. For sure.
Cool. Well, and we can always, chat again on the Amp Hour. So that also helps. Cool.
I'll take you up on that. I think we covered the core stuff, but
I'm sure that there's a lot of people that were shouting about my lack of knowledge about debuggers, but I don't know what they were expecting, honestly, folks.
What I was thinking actually is a challenge. The challenge is, if you think you can explain it better, write it up and share it.
That's a great idea.
Right?
Yes.
It's hard to explain things well, and it takes a lot of practice, and I certainly need more of it.
And there's not as much out there as you'd think there would be. You know what I mean? Like, yeah. So that's a great point. So a challenge from Scott.
Yeah.
Scott, thank you for being on the show. And
thanks.
Twitter, we'll post all your links, I suppose, to everywhere you can be found. So
don't expect for me to see Twitter, because I don't use Twitter.
Where's the best way then?
You could just email me.
Okay.
I'm scott@adafruit.com.
Okay.
You can find me on our Discord.
Yeah, that's probably the best place, huh?
Yeah, but Twitter, I try not to. Not to be on.
That's healthy. Yeah. Okay.
Yeah.
All right. Well, enjoy 3H tonight. Tell everyone out there I said hello.
Thank you. I will.
We'll talk to you soon.
Bye.